University of Hull, where he worked on thermally regenerative electrochemical cycles. Currently serving as an associate professor at Recep Tayyip Erdogan University, Turkey, Professor Tute also heads the Low Zero Carbon Energy Technologies Laboratory. His research output is prolific with over 200 publications in high impact journals, multiple edited books and chapters, and editorial roles in prestigious journals such as Applied Energy, Energy and Buildings, and Nature Scientific Reports. He also served as he also serves as editor in chief for the journals Sustainable and Clean Buildings and Energy Research Journal. Professor Tute's remarkable contributions have earned him global recognition. He was honored as the Young Scientist of Turkey and later as an outstanding young scientist by the Turkish Academy of Sciences. He has consistently featured in the world's top 2% scientist list published by Stanford University, and according to Scholar GPS, ranks among the top 0.03% scientists worldwide in the energy field. His current citation indices are equally impressive, with over 11,000 citations and an H index of 55 on Google Scholar. Today, he'll be sharing his expertise on the topic economic and social aspects of sustainability, a topic that bridges technology with policy, people, and society at large. So let us warmly welcome Professor Erdem Cuce.
Thank you very much for this very kind invitation. If you don't mind, I'd like to give a start as fast as I can because after the session, I have trained to catch up. So let me share my screen first. Can you see my screen now?
Yes, sir.
Thank you very much. So welcome everybody. This is Professor Erdem Cuce from Recep Tayyip Erdogan University. Currently, for the last 2 years, I am visiting professor at the University of Nottingham. Today, I'm gonna give a talk on economic and social aspects of sustainability. So first of all, I'd like to start with the definition of sustainability because it is a very, very wide, very, very common keyword that we come across in papers, project proposals. Very frequently we come across, and sometimes we misuse the definition of it. We ignore, but it's very important. So that's why I give a start from the definition of it. So what is sustainability? Sustainability, in simple words, is the practice of meeting the present day needs without compromising the ability of future generations to meet their own demands, often by balancing environmental, social, and economic aspects. So in this definition, what we understand, sustainability is not the practice of today only. That is also the practice of future generations. So whatever we do within the scope of sustainability definitely will have an impact on future generations, future decades. So we should be aware of the actions, the measures, the plans, projects, proposals, whatever we do, really comply with the circle of the sustainability. So we should take this into consideration. So within the scope of this presentation, there will be, of course, economic, social, and in the environmental aspects. After giving the main fundamental details, excuse me, there is a background noise coming, so could you please?
Participant, kindly mute your audio.
Okay, ma'am.
So economic, social, and environmental aspects, of course, will be considered as a fundamental knowledge regarding sustainability. Then I'm gonna give some practical outputs, practical applications, and their outputs in terms of plans, outcomes and the projected scenarios. So I'd like to talk about later and later slides through my ongoing research projects and papers which fall into the scope of sustainability. So within this scope, we will try to demonstrate how economic strategies combined with social engagement, that's very important, can create long-term sustainability advantages. So if you make a plan, we definitely talk about long-term plans, projections related to sustainability, how we unpack the ideas of externalities and concealed costs, hidden costs, how we analyze the trajectory of, for a specific case, for example, UK's economic development, how we explore innovative economic strategies for achieving sustainability, how we examine the mechanisms behind carbon tax and carbon trading, which are also very common keywords now we come across, how we illustrate a practical example of carbon tax application within a local community. So sustainable development, again, a very common keyword that we come across nowadays. So sustainable development, if it is a development, what we understand that should be related to technology and technological advancements. Development is not just related to technology, but also related to environment, society, and economy. So sustainable development, if we spread a word like that, definitely should cover the circles of society, economy, and environment. And within the overlap of these three circles, people's sustainability. So sustainability is not something like we can easily buy from a shop. So that is an outcome of our efforts, the efforts of past, today, and future. So we may develop, for example, as an instance, we may develop a technology that can be very cost effective, that can be very of high performance. But if it has some hazardous impacts on the environment, we can't consider this technology as an environmental technology. That's why it's a sustainable technology. So we should be very careful while using the terms related to sustainability. So achieving sustainable progress requires a balanced integration of economic growth, social well-being, and environmental stewardship. The natural environment serves as the foundational support system for economic activities and their expansion, and economic advancement fuels investment and innovation, driving the creation and application of new technologies. So these are all related to each other. Definitely, there are some overlapping sections, and we should take all these into consideration. How about the summary of the social aspects of sustainability? Different realms actually fall in this scope. We can't split them into some specific number of sections, but we can say like social sustainability covers agriculture, income, quality, access to sources, access to maintenance, and everything. So we need to cover different aspects of them if we want to speak about social sustainability. So it's a growing trend in urban planning across the UK and Europe, in both developed and developing countries. We're going to try to talk about the benefits of adopting social sustainability and how to develop a novel approach to evaluate social sustainability through different practices we will try to analyze and assess. So in this time of the slide presentation, I'd like to give an example regarding a university case as a sample study. And I'd like to talk about the economic and social sustainability through this case. So in the UK, as you are all aware of, the universities are based on tuitions. So tuitions, something like each university student should pay annually. And these are very high number of figures, very difficult to be afforded by the rest of the world, especially the ones coming from the developing countries. But how these people asking these huge amounts of tuitions, and at the same time they are somehow finding places in the ranking world ranking sites, because they put a keyword like sustainability in educational quality. So how they are providing this, how they are maintaining this when we have a look at in detail. So to be able to make you sustainable as a university in the UK, first of all, you should know you can't compromise from the quality in research, quality in education, and quality in satisfaction figures. How to make students happy while they are in. You should teach them where they are. You should teach them how motivated, how engaged, how dedicated they are to the university, to the college that they are belonging to. You should put good relationships with the students, with the alumni. You should put relationships with the industrial partners. And you should make not only students, you should make your staff happy as well. And you should pay good salaries to your staff. And to be able to secure your reputation in the world, you should put good targets, measurable and good targets. So within this very, very simple, specific case study, what we understand, it is a process driven by economical figures like tuitions. But to be able to make it sustainable, definitely you should touch society. Your society is your students, staff, industry partners, your stakeholders, etc. So you should somehow engage with them, collaborate with them, and make them happy as well. So there are many, many overlappings. We can increase the number of circles here, but what I'm trying to say, it's not a simple process. Just press the button and get it. How about the environmental impact with the economy and social sustainability? So whatever you do in terms of meeting the prerequisites of the sustainability for economic and the social side, social aspects, definitely there will be a reflection of these measures, of these actions on environment. And environment, if we think thermodynamically, we can't isolate the system from environment. When we consider a system in thermodynamics, always we make it engage with the environment. So environmental impact will be your mirror while you make a plan for sustainable actions, for sustainable actions. So, for example, we are aware of the carbon footprint of buildings, carbon footprint of different areas like transportation, energy generation systems, plants, etc., waste, blah, blah, blah. But what you do, you make a plan to reduce the carbon footprint of these sectors. For what? To be able to minimize their influence on environment. So that's a strategy. What else? You make a plan while you are reducing the, for example, carbon footprint of your plant. You make a plan, but that plan definitely will based on some financial matters. These financial matters definitely again should be related to environment. So what's gonna be the outcome of your measures? So in terms of finance, in terms of the reduction in emission figures, what's gonna be the reflection on the outcome of these measures need to be taken into consideration altogether. Ecological economics is another keyword that I'd like to talk about a little bit within this presentation. So it's an emerging interdisciplinary area that explores the dynamic interplay between economic systems and the natural environment. So economy functions as a component within the broader human environment system. Economic models must align with the fundamental laws of biophysics. There are, of course, inherent limits to replacing natural sources and ecosystems within human-made inputs and technological knowledge, and economic policies should definitely balance goals of efficiency, fairness, and long-term environmental sustainability. So, economic policies, the decision makers, for example, take an action to make something better. Definitely, these are based on some figures like efficiency, some, for example, increasing the production rates, etc. But there are some indispensable parameters that we need to also bear in mind, which is fairness, quality, environmental sustainability, etc. And we will see the reflections of them in the next slides. So externalities. Externalities refer to the intended side effects that influence the consumption and production choices of others. These effects occur without being reflected in the product's market price, meaning the cost or benefit to third parties is not accounted for. Externalities occur whenever the decisions or actions of one economic participant affect another's well-being, either positively or negatively, without the first participant shouldering the associated cost or without enjoying the benefits. So how many types of externalities we have? We usually talk about two externalities, which is beneficial and the adverse externalities. The beneficial externality basically enhances the possibilities for both consumption and the production, creating positive ripple effects. On the other hand, adverse externality hinder consumption and production opportunities, leading to negative consequences. So if we would like to talk about the benefits of positive externalities, we can easily say, for example, when companies operate next to each other, they often exchange ideas, they collaborate together, they create proposals together, projects together, and innovations boost the productivity through shared knowledge and through the collaboration they do. So that is the positive sides of externalities. How about the negative one? Excuse me, because of
Participants
the
kindly
background.
muted. Participants kindly muted.
Negative externalities, for example, smoking or other activities that produce pollution, impose costs on others, or a factory that pollutes the environment, of course, hurts nearby residents. So these are the negative externalities that are given access. So what are the government interventions to stop or to minimize these negative externalities? Pricing strategies are definitely utilized by governments. So, for example, carbon taxes or greenhouse taxes. So what they do, they implement a tax plan to be able to minimize these effects, and they mandate firms to limit their production to the social optimal quantity to minimize external costs. So there are different strategies of different governments. So in this slides, I'm gonna give examples from UK and Turkey side. So private sector solutions to address negative externalities. There are some good examples here. For example, if the river, for example, there is a river, if the river under the individual ownership, for example, owners can impose fees on companies that pollute the water. For example, they can levy charges on individuals who pollute less, and the liability laws make firms legally responsible for the damages they cause. So there are different actions that are adopted by different countries. How much the importance of the unveiling the true costs regarding the environmental aspects. So decision makers, so the questions are here, the critical questions. Decision makers are really aware of the hidden financial impacts that environmental rule can impose. So what are the main causes behind the significant unseen expenses, and which key business decisions are most influenced by the hidden costs? Expected answers might be, for example, difficulties arise when consolidating data across multiple plants and various functional units, isolating the environmental cost factors in process modifications, as so several goals can be highly intricate. Crafting costing frameworks becomes particularly challenging in sectors subject to stringent environmental regulations, like in the UK. Significant underestimation of concealed expenses often results in less than ideal decisions regarding cost management, like the cases in Turkey. So concealed expenses can skew variance analysis, leading to inaccurate product pricing. That distortion may result in flow decisions regarding product assortment, facility shutdowns, and capital investments. So factors contributing to hidden costs. What are the main reasons, root reasons of the hidden costs? Compliance with environmental laws and standards, modifications in the composition of raw materials, variations in the ratios of input resources, consumption of energy resources, and additional indirect labor expenses borne by companies. So there are, of course, some indispensable consequences of the hidden expenses, like for the heavy industries, rising energy prices will result in reduced wages and diminished employee benefits. Again, rising energy costs will hinder access to affordable education, healthcare, utility services, and undermine social equity. If we talk about the drivers of economic growth, we talk about four main splits like natural assets, tangible capital, human capital, and social institutions. So what comes to mind when we say natural assets? Of course, raw materials, forest resources, and processes that absorb carbon. How about the tangible capital? Machinery, buildings, transportation networks, and other physical infrastructures. Human capital, collective education, skills, knowledge, and labor force, and social institutions, governments, organizations who take place in this manner. So economic growth, when we say economic growth, for example, we can't talk about just a certain period of time, like, for example, UK faced, especially after Brexit. Economic growth, GDP growth sharply dropped actually after the event, but then a sharp increase and then a gradual uh, tendency shown for the UK case. And for the Turkey case, much more stable growth in the economy is shown here. So when we talk about economic growth as sustainable growth, or we may have a look at the decades, not a certain period of time. That's why I put that there. So economic development and environmental impact, that's usually given, explained with the Kuznets curve. So Kuznets says, maybe in the next slide, I'm going to make it much more clear to you. Across the globe, economic progress is increasingly confronted by critical environmental issues, including the urgent need to prevent severe climate change and alarming decline of biodiversity and natural habitats. So if you have a look at the Kuznets curve here, says at the early stages of economic development, reducing pollution, minimizing the greenhouse gas emissions is often seen as a low priority. Usually it is neglected. Usually it's ignored. When the income rises till a certain point, the pace of the environmental degradation slows down. Why? Because when the income rises, people start to pay more attention to the environmental matters. And after a threshold value, when wealth reaches a good level, then people start valuing clean environments, clean air quality, and this kind of figures. So that's given with the Kuznets curve. So how the environment influence the economic development? Of course, there are many things to talk about this, but we can easily say, yeah, direct and indirect contributions we can talk about. For the direct contributions, for example, it supplies essential inputs like water, timber, and clean air. So these are the mandatories for the daily life. And there are also indirect benefits like supporting the vital ecosystem functions, including carbon storage, water filtration, etc. So environment, as I said, it's the core of the sustainable development for any policy in developed or developing countries. So environmental policy framework, again, differs from country to country, but there are now some overlapped targets, overlapped strategies, measures for even of developed and developing countries. These are like net zero carbon buildings, thermal insulation energy efficiency measures, renewable energy integration into the built environment, industrial facilities structures, sustainable urban planning, water conservation and management. The rest also, yeah, can be expanded, but these five can be considered as the main measures both the developed and developing countries now adopting and trying to make themselves ready for the standards. So carbon economics. When we say carbon economics, two common, again, keywords coming on table, which are cap and trade and carbon taxation mechanisms. So to be able to achieve a sustainable planet, we need to control the carbon emissions, or in general meaning the greenhouse gas emissions. And while you are doing production, while you are manufacturing, producing something, definitely there will be some CO2 emittance to the environment. That's indispensable. But the goal is to make it at a controllable level, and putting some taxes to control it. So carbon pricing strategies, basically, we have to understand first the carbon tax, the meaning of carbon tax, what is its important regarding the combating the climate change, how effective is the project, and what is the adaptation of these process globally. So, understanding the carbon tax and emission trading, we need to underline the statements like polluters bear the cost of climate change, health issues, and environmental degradation. So that is acceptable for everybody. Carbon pricing ensures the energy and produce prices reflect their true environmental impact. Carbon tax applies a fixed cost per ton of CO2, trading limits total emissions through permits. Higher costs of polluting activities push firms to invest in renewable energy and efficiency measurements. So this is very, very important. So because of the new taxing system, carbon tax system in developed countries, so companies, firms, and factories stimulate into renewable energy technologies to check their carbon footprint and carbon emitting figures to minimize them and to get incentives from the governments, subsidies from the government. So different governments put different incentives in this regard, and they are now really stimulating into this area. So carbon tax and permit auctions create public funds to support renewable energy installation and social programs. These are also very, very common now in the UK. Carbon tax and the permit auctions asking and encouraging leading the companies to the renewable energy sector, or in terms of the energy losses, for example, energy losses to check their installation policies, making them compatible with the latest building code standards. So these are very, very now common, adopted by the industrial factories and firms in the UK. These mechanisms are central to meeting Paris Agreement targets and national net zero commitments. So carbon tax operates very, very simple. The higher CO2 levels, the higher tax you pay. So a fixed charge is applied for every ton of CO2 emitted. Industries, factories, and power plants must pay according to their emission levels. And higher emissions, as we can imagine, as said, higher costs and incentivizing cleaner technologies. Governments can reinvest collected revenue into renewable energy, insulation programs, and social support. So again, in this time of the presentation, I can easily say, for example, if the policymakers come up with an idea, definitely it's not just minimizing the CO2, it's also an issue that support the companies to be able to check their production capacities without compromising the performance outputs of the company, without compromising the employability potential of the company. So definitely these are all need to be considered together while they are making an action. So carbon trading is also a topic. Cap and trade framework, industries are given an overall cap, something like a limit on greenhouse gas emissions. This is actually a permit. Each permit allows the release of a fixed amount of CO2 equivalent gases. Permits are allocated often via auctions, creating a tradable market. Firms with lower emissions can sell surplus permits to high emitters. So it's something like a balance between the good ones and the bad ones, or good examples and the bad examples. Companies are motivated to cut emissions to save or profit from trading. So incentives come from the government actually to be able to minimize their CO2 levels and to make the process, the production stage, whatever it is, much more eco-friendly, environmental friendly, and driven by the renewables. So advantages of implementing a carbon tax, it is something like, of course, in terms of environment, in terms of the safety, security, air quality, and the other performance figures and sustainability of the future generations, very, very important. But if we talk about the drawbacks, we can easily say like, okay, drastic measures coming to the firms which need to be complied within a short period of time definitely will play a key role in the reduction of the production capacities, because each production means CO2 emission, And when you ask these people to cut your CO2 emissions down, basically you're asking them to cut down their production capacities. So that means also the reduction in the employability. That means also reduction in the development, economic development. So definitely there should be a balance, and this balance should be driven by equity. That's also very important. I put here a figure for the UK and Turkey's carbon pricing. So I'm going to share my slides later on with the organizers. So you may have a look. It's a very, very interesting one. But I'm going to pass this slide. So UK carbon price mechanisms, there are different schemes regarding the carbon tax and trading in UK, which is the first one is carbon price support CPS. CPS introduced in 2013 applies a carbon price floor on power generation to encourage a shift towards low carbon technology. So that already started more than a decade ago. So a CCL climate change levy implemented in 2001 as a tax on non-domestic energy consumption, initially exempted renewables, but this exemption was removed in 2015. Indirect carbon pricing, taxes on fossil fuels function as indirect carbon pricing, particularly effective in the energy and transport sectors. Paris Agreement and international implications, carbon pricing mechanisms are seen as critical tools to accelerate the low carbon transition and achieve Paris Agreement targets. And carbon intensity metrics, UK regularly measures sector-specific CO2 emissions, sectoral CO2 emissions. That's very, very important. And by 2021, UK greenhouse gas emissions had decreased by 27 compared to 2007 levels. So they are regularly checking their CO2 levels, taking actions for decades. And the sectoral CO2 assessment analysis play a critical role in doing that. How about the case of Turkey? So Turkey doesn't yet have a direct carbon tax policy. However, through the energy and fuel taxes, approximately 31% of national emissions are indirectly priced. Carbon tax, and in terms of carbon tax and maritime transport, since last year, ships entering and leaving the ports have been subject to a carbon tax, and this marks the country's first sector-specific carbon pricing application. TRETS also takes place since last October, with full implementation plan of 2026 and 2027. The system is under development with reference to EU ETS model. Climate law and ETS legislation on 2nd of July 2025, the climate law was adopted, giving Parliament the legal authority to establish and regulate the ETS and carbon markets. So that's a comparative table for UK and Turkey. So UK, in terms of carbon tax and trading, leading something like 2 decades, to be honest, compared to Turkey. So what are the key environmental policy areas? So we talk about different scenarios for sustainable development, and that development covers the development of society, economy. So what the key area? The key areas, as I said, can be split into 5 for both developed and developing countries. So these are net zero carbon buildings, thermal insulation and energy efficiency, renewable energy incentives, sustainable urban planning, and water conservation and management. So these areas are very critical. Why we say that these are critical? Depending on the lion's share on the global energy consumption. So they have a lion's share on global energy consumption, and as a consequence of this, they play a key role in CO2 emissions and other greenhouse gas emissions. So that's why sector energy consumption in UK urge policymakers and the industrial partners, factory stakeholders to pay attention to these 5 parameters. So importance of using thermal insulation, I'd like to talk about and give a start. Now, from now on, I'm gonna give some very, very brief outcomes from my past ongoing and the future paper and project proposals. So importance of thermal insulation, and nothing to say about that, it's very clear. Buildings currently constitute of 40% of total energy consumption in the world. So whatever we do in the buildings as a reinforcement, as a retrofit, plays a key role in the reduction of energy consumption figures, and by doing so, in the reduction of greenhouse gas emissions, or simply CO2 emissions. If we have a look at a building shape, a building sketch, so building consists of four main elements. So external walls, windows, roofs, and grounds. And there is also one another term which is related to energy loss from the buildings, which is air leakage. And air leakage roughly constitutes about 17% of energy loss from a building. So if you have a look at the windows and the external walls, we can say more than 70% of the energy loss from a building or from building sector attributed to these main components. Why? Because still, again, in both developed and developing countries, we are still using conventional materials and conventional techniques while we are doing our buildings, while we are retrofitting our buildings, while we are refurbishing our buildings. And that's a mistake. And these are far, far away from meeting the latest building standards, not only for UK, but also other European countries. So I'm gonna now give some details from my past publication stories. So this is a Victorian house. This is a Victorian house in Nottingham University Park campus. That's a Victorian house, conventional Victorian house. Normally, when we do a coheating test to understand what's going on in terms of the thermal behavior of this building in real operating conditions, there is a tragedy. There is a tragedy we come across in terms of the sustainable development goals. Why? We talk about our system by itself like a building, and we assess its interaction with the environment, with the surrounding environment, and we understand most of the energy consumed in buildings is painting to the environment, and it's uncontrollable. So what we did, for example, rather than using the conventional insulation materials, which bring heaviness and the reduction in the living spaces to the building, we use thermal superinsulation solutions, for example, in a specific building. We don't do it to the entire building. We just grab a test bedroom within the house and internally insulate it just with 20 mil thick aerogel flexible thermal insulation material that we develop in our lab. And we internally insulate this building. Then they have a look at what's going on after the retrofit. What we see that heat loss coefficient of the test bedroom, normally it was 17.15 watt per Kelvin before the retrofit, but it dropped to 6.29 after the retrofit. So what we can easily say, there is a big reduction in the heat loss coefficient. That means that much, if it is 70%, if it is 80%, that much reduction in energy consumption figures and that much reduction in the greenhouse gas emissions. So it is something like a goal. A goal for what? A goal to meet the latest codes in the buildings of the UK. We need to make the buildings more strict, more tight, to be able to adapt it with the latest standards. That's not just energy figure. That's not just energy assessment. That's also an assessment of the quality, global warming, climate change, local environment performance and quality. So that is what we get experimentally in this specific case. So that's the entire view of the house. That is some photographs from the internal retrofit process, and that's the coheating test methodology that we develop here. Then what happens, for example, I'd like to also talk about here, which is very, very interesting. When we do something, we need to know the previous and the future of the work. If you make a wall, an external wall, internally insulated, you should take into consideration what's going on in terms of the separating walls that I notice here on the right hand side top of in the slide. You don't basically insulate and separating wall because the next door is at the same temperature with the test room. But when you make one side of the room, one side of the house much more thermally resistive, there will be definitely a thermal bridging impact here through the separating wall. Normally it's not an insulated part as we expected, but at pre and post retrofit tests we easily see that. So there is a huge amount of thermal bridging takes place through this external wall, which is, as you see from here in at the pre-retrofit case, 0.66 watt per square meter. That's heat flux value. But after the post-retrofit is 5.86 watt per square meter. So what does it mean? There is almost 10 times more heat penetrating from the separating wall to the environment. Because when you make a plan and thermal insulation plan to make your building adaptive to the sustainable development goals, you should take all the aspects of the building into consideration. You should have a look at all the parts of the building as a measure. Otherwise, you will fail. So we know normally actually what's going to happen before this retrofit. But to be able to justify this, we do and publish these experimental results. So as I said, sustainable development goals, how we are going to achieve these goals. You can't achieve these goals with the conventional insulation materials. Definitely, you need to think about novel, organic, nature-based, biomimetic materials that need to incorporate it, integrate it with the conventional ones, or you need to come up with your own material. Here, for example, we develop our own insulation plasters to be utilized as external building material in the built environment. We develop some insulation plasters. We integrated on the conventional materials, and we simulate them in the simulated environments. Through the coheating test, we have a look at the thermal behavior of the materials. So what we have here, for example, for the conventional briquette material, we get a U value, overall heat transfer coefficient, that's the U value's definition. We get a U value around 5.5 watt per square meter Kelvin with the conventional one, but with the 2-2 briquette, that means 2 centimeter internally and 2 centimeter externally insulated with our null insulation plasters. With this briquette, we can easily drop that level below 3 watt per square meter Kelvin. That reduction is very, very important. Again, no need to speak about it because of the energy consumption figures, because of the greenhouse gas emissions. Then, as I said, we need to make our building elements from now on natural materials, so bio-inspired materials. We need to inspire from nature. To be able to meet that goal, it's also a sustainable development goal. We take nature as a model and we use bamboo fibers in our conventional briquette production. This time, we don't use a conventional briquette, for example. We use natural materials to come up with these nature-based insulation briquette. And we again do the same testing. And we have a look at the behavior of the briquette, and we get very, very good results. So if we use 6% mass fraction bamboo reinforced briquette, we get a U value around 2.5 from the product. So what is the methodology? The methodology is testing material in the simulated and real operating conditions. You see the samples that we develop here, for example, and you see the products, how we are coming to the latest stage. We've produced the material, and then we do coheating tests, we do CFD analysis, and we compare the numerical and experimental stuff, and then we retrofit test building, for example, or the wall, one of the walls of the test building, and we have a look at, we assess and investigate the thermal behavior of the buildings. So basically, we measure the heat flux, we measure the temperature difference across the building material, and then we calculate the overall heat transfer coefficient through this. We also talk about, you remember, the windows. Windows also indispensable parts of the buildings, and at the same time, very, very poor elements in terms of thermal insulation characteristics. So normally, still in developed and developing countries, the fenestration products, the window industry, is dominated by the double glazed windows. I time to time visit India, and I see whatever I see in India. I see whatever I see in India in terms of the building fabric and the building physics configurations, thermophysical properties, the same in Turkey and the same in the UK. In some specific applications, for example, they fill a gap between the panes with argon, with some specific inert gases to make it much more thermally insulative. But within even the triple glazed window structures, you can't get a U value below 1.5. So that's why when I have a look at the standards of the latest codes, for example, the UK building codes tell me to meet the U value below 0.8 from a glazing product. That is impossible with the conventional glazing techniques. So what we, for example, try to do here through different projects funded by EU and other UK-funded organizations, we develop, for example, different glazing technologies, like in this specific case, vacuum tube window. We bring separate tubes evacuated at a pressure below 10 Pascal to be able to minimize the conductive and convective losses. We come up with a product with 28 mil thick, and then we have a look at the U value. So these are some full-end profiles, static contours of temperatures. So we get a U value from this product depending on the diameter of the tube below 0.4 watt per square meter Kelvin. If you make the tubes 60 to 70 mil, you can get a very, very low U value from this product. For example, only the problem of this product is the visual quality, but we don't use this window technology for example, front glaze in buildings or offices. For example, for the storage areas, the windows, glaze areas of storage areas where the visual quality is not important. And if it is quite large to the entire rest of the external wall, you can consider this technology. Vacuum tube window technology is not a new technology, but don't have a history more than 2 decades. So Pilkington is the first successful application of vacuum glazing technology. That's a company based in the UK. When we have a look at the U value of this product, for example, is 1.2. Okay. But if we make an investigation in detail in this product, what we see, there are support pillars. Support pillars made of conventional steel-based materials, which are highly conductive compared to the vacuum medium. Okay, so what we do here, for example, as a further improvement in the technology, we optimize the number of pillars at any section, and we replace the conventional steel-based support pillars with the translucent aerogel material. So by doing so, we add a U value around 0.46 from this product, which is very, very outstanding. Another technology we developed, for example, for the windows, to be able to meet, again, the sustainable development goals, not for anything else. This is called solar pond window. Solar pond window is a window technology that consists of a different number of layers with the inert gases and some specific liquids. Why we use some inert gases and specific liquids all together within a window pane, especially in harsh climatic conditions like Middle East in summer? Yeah, we try to get benefit from the high specific capacity of these different layers. We aim to stop the penetrating solar radiation within the liquid and the inert gas environment medium. And in the nighttime, we aim to discharge the energy to the out because of the temperature difference from daytime to nighttime in these regions. So in this product, with some specific insulating salt solutions, with some specific inert gases like krypton, we get a very, very promising U values around 0.7 watt per square meter Kelvin, which is also very outstanding. We all publish all these papers actually in good journals before. So another technology for the facades, for the sustainable buildings that we develop is the heat insulation solar glass, or further we improve it with the name of thermally resistive PV glazing technology. So it's a basically an thin film amorphous silicon PV glazing technology. We reinforce and support this glazing product behind with some specific inert gases, and we compare the thermal behavior of this product with the other conventional uh, argon-filled double glazed window, argon-filled double glazed window with low V, and air-filled double glazed window with low V, low emissivity coating. And we get a very, very good U value from this product as well. And again, we publish it in good journals. So as I said, for the sustainable development goals, you need to generate your electricity in a clean way as well. So what can be done? India is very, very abundant in terms of solar potential. So you can do it easily. So you can warm your place in winter. You can cool your place in the summer. You can dry your products by sun. You can do everything as you are aware of through sun. So for example, thermal applications, maybe you're not that much interested in this technology because you're abundant of solar radiation. But in the Scandinavian climates in UK, these technologies are very, very in the center of interest. Basically, in the summertime, because of the cooling effect of the chimney through the outlet wind, we get a chilling effect inside. In the wintertime, as you are able to preheat the outcome air, you can easily preheat air and direct it to the indoor environment. So basically what we do optimization stuff here through different approaches for different values of the air gap. We have a look at the indoor temperature quality distribution, etc. So solar chimneys also a good scope. Actually, now we are planning to integrate it with the houses, with the factories, with the firms in the UK. So small scale solar chimney power plants are in the center of interest. They are uh, able to generate electricity. At the same time, the benefit of the collector can be utilized for agricultural and livestock applications. It's something like a greenhouse in there. At the same time, you can get benefit from this system for desalination water. For desalination purpose, system can be utilized. You can utilize the ground as a storage medium, and you can get benefit from this energy stored on the ground for the uh, uh, after the sunset hours. So what we are doing here, we are basically checking the energy production potential of the plants, and at the same time, the energy stored on the ground can be utilized for different purposes, for cooking, drying, sterilization, for different purposes, and for the desalination as well. So we are looking at the potential of these technologies. For different operational design and environmental conditions, we look at the behavior of the system and try to optimize the performance outputs. As I show here, for different, for example, soil radiation conditions and beam conditions, for different ground slope or collector slope conditions, for different chimney divergent and convergent design conditions, we have a look at the behavior of the system and try to optimize the performance parameters. Yes, I'm passing all this. Yeah, divergency and the convergence is an issue in solar chimney power plants. As I said, now we plan to integrate these small scale plants next to the UK building stock, characteristic conventional UK building stock, and we aim to make them chill in summertime and warm in the wintertime. At the same time, we plan to generate electricity from the plant, small scale plant. So we, for example, in the specific case, try to optimize the optimum divergence angle to be able to maximize the efficiency and the power output from the plant, and which we got here 3 to 5 as the AR value. AR is the chimney outlet area to chimney inlet area, the ratio. If you have, for example, in a factory, in a firm, or in your house, if you have some waste heat, you can easily integrate the waste heat to the ground of your solar chimney power plant, small scale plant, and you can get benefit from this waste heat, as an improvement in the power production and also in the efficiency figures. So here we carry out some simulation works analysis, and we compare it with the conventional case, and we see the enhancement. So in terms of PV and PVT and thermal collector side, many things being done by my subgroups, MSc and PhD groups. So all our goal is to minimize the waste heat, actually, waste heat, the heat losses from solid collectors, or maximum solar absorption. That is our goal to make. And to be able to do this, as you can imagine, there are different techniques, and we approach the methods experimental and numerical, and have a look at what is the best scenario that we can get from a solid collector through different heat exchanger designs, heat absorption strategies and measures. We look at the temperature distribution with our solar collectors. We calculate our thermal energy content, thermal energy product from the system, efficiency of use, etc. From the PVT side, of course, PVT is not a novel technology, again, lasting for the last four decades, maybe more. But still, there are some research ongoing on there, and we are still publishing in good journals. How we are doing that? Because of the novelty of the research. So PV is something like needs to be operated at a lower temperature, but and usually the planters don't care the waste it actually dissipated to the environment. They just care the electricity output from the plant, because that's making money. But what we say, as you are aware, so you can get benefit from that wasted as well. So there are different ways of doing it. There are different approaches. Here, for example, we use a bifluid application. So the water is a heat transfer fluid from the beneath of the collector, PV cells, can be integrated, and from the top part, air as the secondary transfer fluid can be utilized. And we look at the experimental and numerical the output of this adoption approach in terms of efficiency and thermal energy content. In terms of sustainability, also we do some attempts, like, for example, doing our own collectors with the waste materials. Waste is also an issue, as you see in my slides. So here, for example, from the waste cans, we develop our own solid collectors, and for different operational conditions, we have a look at the thermal energy content of the collector, the efficiency is calculated, and then we make some plans to integrate this technology from waste to energy technology to buildings, to roofs, to buildings, facades, and also to factories, to be able to meet their zones. Water, again, was a scenario, you remember. It's a very important thing. Especially water scarcity is an important problem of the world today. So to be able to meet our fresh water demand, there are different technologies now that countries are utilizing. It's going to be very costly process, of course, year after year. So countries definitely should get used to it. So water desalination can be done from different systems. For example, in this system, we do it with a single slab solver still, with a sensibly storage beneath the absorber. Again, through booster reflectors, as you see from the sketch, we try to enhance and improve the thermal energy content of the system, and then the water productivity, of course, from the plant. And we test the system for different, for example, testing days, and look at the productivity rates. Then we enhance the productivity by integrating the system with, for example, a cooling system on the aperture surface. Aperture surface here, for example, with the cooling nozzles automatically done by some Arduino-driven device. So what basically we do here, we speed up the condensation process and increase the water productivity in this plant. So different attempts being done for meeting the water demand, fresh water demand. So design is also an issue. For example, here, dome style, for example, is utilized to be able to maximize this solar penetration through the aperture glazing. Design aspect is studied here. For a time-dependent case, we look at the hourly productivity, water from the system, and also the temperature figures for the thermal performance assessment. So social aspects of sustainability, it can be split into 6 parts. It's also very difficult to make it, classified in some specific parts, but we can do it in 6 parts, like equity and justice, public health and well-being, employment and skills development, social acceptance and climate policies, community engagement and behavioral change, and a global social dimension. So when you make a plan. When you make a plan, definitely should bear in mind like it should be equal for everybody, and it should be a just policy, because we know that low income households and high income households within the community, if they are subject to the same tax rate, that's a different scenario. So it's not a fair distribution of the taxes. So that's why if you make a plan, definitely the costs really to greenhouse gas emissions, it should be distributed fairly. We definitely should protect the vulnerable groups within the community, and we should make them believe within the action. So public health, while you are doing that, you should definitely consider the public health and well-being. So air pollution is a very, very important thing. Air pollution is one of the biggest environmental health risks globally. Fossil fuel burning, smoke, and particulate matter cause some important diseases like cardiovascular diseases. World Health Organization reports 7 million early deaths unfortunately happen due to air pollution. Sustainability policies reduce reliance on fossil fuels. That's what very, very important. Low hospital admissions reduce healthcare costs for governments, and cleaner, greener urban design also means safer streets, better quality of life, and more active lifestyle. So we see before and after. That is the scenario that we don't like. So smoke and dirty air quality very low on the left-hand side, heavy traffic and fossil fuels based on fossil fuel sources. Respiratory disease takes place very, very often. But on the right-hand side, that's the ideal scenario. Clean air quality is very high with the green spaces, no global warming and no climate change, renewables and the public transport. This and that. So we need to increase the number of good examples. Employment and skills development. That is a scenario that the uh, fossil fuel owners, for example, don't like the scenarios like they say, okay, it's very, very difficult to make a transition from fossil fuels to renewables in a short period of time. That is true, but definitely there should be some plans to do it, because we know that renewables can create twice as many jobs as lost in fossil fuels. So it is a reality. So we should make, both developed and developing countries, we should make a plan to switch into renewables as fast as we can. Social acceptance of climate policies. So fairness is the most important thing. So fairness and trust are very, very important. Whatever we produce, we develop as a measurement, as a measure. So definitely they should comply with the equity, they should comply with the fairness. So if people don't trust your policy, definitely they resist them. So it is indispensable. So when revenues are reinvested in society, acceptance grows, and fairness is the key, as I said, to make a climate policy possible. So you should touch all the people at different levels of income from the communities, and definitely there should be a different scheme of taxing. Community engagement and behavioral change. Yeah, that's a transition actually. So when you take measures, definitely there will be an outcome of these measures. So it's not very easy, for example, transition from diesel or petrol cars to electric cars. But what's seen now within the last 1 decade, there is a big stimulation into electric cars industry. So it's a process, and definitely that needs to be done for all sectors, not just the transportation sector. For the buildings, definitely each building should cover its demand by renewables as fast as it can. So it's indispensable. It's not just the duty of the developed countries that should be the responsible for everybody in the world. So that is the scenario. So everybody dreams alive, like everybody goes to work by cycling. Yeah, yeah. When we make a projection for that, so we can't imagine the reduction in the CO2 level within a year. So, but we can't expect that happens, within 1 second. That's gonna take time, but we should make our plans ready for it. So climate change is not only an environmental challenge, but a social one, reshaping lives and forcing immigration in the most vulnerable regions. Those who have contributed to this is very important. Those who have contributed to the least to global emissions are often the ones suffering the most. Okay, so we should be very careful while making our plans. That's the responsibility of decision makers, of course, but it should be fair and it should be equal. True sustainability demands global solidarity, from climate finance to shared responsibility, because only together we can build a fair and resilient future. Yeah, thank you very much. Yeah, this is Professor Erdem Cuce, currently in the UK, but my position in Turkey. I am working on the areas listed here: solar chimney power plants, solar photovoltaics, solar thermal applications, thermal superinsulation, low carbon technologies, innovative HVAC, thermal energy storage, thermoelectric coolers, thermoelectric generators, wet disk recovery. The areas here listed are the sub areas that my groups are working on. So I was interested in doing some research together in collaboration, more than happy for that. So feel free to reach out to me for any future collaborations through my email, LinkedIn profile, social profile, whenever suits you, whatever suits you. Yeah, thank you very much. If you have any questions, more than happy to take them. Thank you very much.
Participants, kindly ask any question if you have. Is there any question? Sir, thank you so much. That was very wonderful and insightful session.
I ask one question, please.
Yeah, sure, please.
Ma'am, I asked sustainable development of the how to generate and how to innovate.
Can I take the question again? Sustainable development?
How to generate and how to create.
How to generate and how to? I
Create
can't get your voice well.
climate change.
Sustainable development, as in the slides, I explained, it is not something like we can get easily.
Yes.
It has different subsections. So when we talk about development of economy should be in there, development of environmental quality should be in there, and development of social acceptance and quality should be in there. Sometimes we develop technologies, for example, electric cars, but people resist to them. But we are all aware of the good environmental outcomes of this technology if we make a transition, fast transition. But that takes decades because it's not in the hands of us. It's in the hands of the governors of the market. So now the current market dominated, for example, by the diesel and petrol cars, and still the manufacturing bans of these car production centers ongoing. So even if they are saying the same thing with us, that will take time because they can't get rid of their income. So it is something like a transition that will take time.
Sir,
But
sir, please. My question is sustainable development. What is the environmental and how to get it? You say carbon dioxide is generated by all things,
yeah,
but how to reduce everything will be all the manageable things. But
is there any answer of this?
how to reduce everything basically on the base point where base point.
We don't want something to reduce, to be honest. We don't want something to reduce. Otherwise, we get rid of the technology. So if we want high technology, technological advancements, definitely we should consume much. That is indispensable. We should consume much. But while we are consuming much, what is the target is? The target is, while you are consuming much, you should bring a threshold to your CO2 level, to greenhouse level, and have to do it by integrating or stimulating into other renewable eco-friendly technologies. That is the way of doing it. It is not a question and there is only one answer of it. You should check, as a, for example, factory owner, you should check what is the production mechanism in your factory, what is the carbon footprint of your production. Within that carbon footprint figure, what can be done to make it low? And incentives now from the governments are very clear. For example, if you make it 10% down, you will get that intensive. If you make it, for example, 50% down, you will get, for example, 50% off from the PVs on your roof project. This and that. It's very clear, but it is not something like, determined with the boundaries, like you should do this and do that. But we don't want, in simple words, we don't want to reduce our energy consumption figures. We just want to aim to reduce our CO2 levels as a consequence of this consumption. Thank you very much for the question.
Thank you, sir. Is there any more question? Okay, sir. Thank you so much. Your session was very insightful and your experience very wonderful for us. So moving forward, our thank you so much, sir.
Thank you very much. Thank you very much for the attendees. More than happy to be here. Thank you. Take care of you.